Today's video lesson is on an introduction to circles. We'll look at characteristics of circles, properties of circles and tangents, rules for tangent segments, and solving tangent segments. If the radius of a circle is 10 centimeters, what is its diameter? The radius, remember, goes from the center to the outside of the circle. The diameter goes the entire distance across the circle. So if the radius is 10 centimeters, the diameter would be 10 plus another 10, or 20 centimeters. Always remember that the diameter is twice the radius. Here's an example of where you might see circles. There's many examples in the news, in a newspaper, on the internet, where you will see a circle graph. A circle graph is one of the things that we'll study in our introduction to circles. Here are some definitions. With each of the definitions, the picture goes with the examples from the definition. We have the circle and how to name it. It's named by the center. A circle is a set of all points from a fixed point, which we call the center, and it's named by the center. The radius is the distance from the center to the outside of the circle. Some examples are the segments listed: AC, BC, and DC. Congruent circles have the same radii. Congruent means the same shape, same size. Diameter, again, goes through the center of the circle all the way across. Endpoints are on the circle. A chord is also a segment in a circle, but it doesn't necessarily have to go through the center. A diameter then is really a special kind of chord. So an example would be DB is a chord of the circle. Then we have some other things that you might not be as familiar with. A secant is a line that intersects a circle in 2 points. Typically a secant is a line. It's actually an extension of a chord if you really think about this. So this is line EF. A tangent is a line that intersects a circle in exactly 1 point. EG is an example of a tangent line. The point right here, E, where it intersects a circle, is called the point of tangency. And then we also have something called concentric circles, which are the same center and different radii. An example of this would be a bullseye. In addition, we have the term common tangent. It's a line that is tangent to 2 circles. A common external tangent does not intersect a segment that joins the centers of the circles, and a common internal tangent, which intersects a segment that joins the center of 2 circles. Here's an example. Give the center and radius of each circle. Describe all common tangents. Here we can see that the center of the circle is at 2, 1. The center of the circle on the little circle A has a center of points 0, 1. The radius of this circle is 3 units. Here's the radius. The radius of this one is 1 unit. Describe all common tangents. So this right here would be considered a common external tangent because it intersects both circles in exactly 1 point. It looks like it's more than 1 point. Technically it's 1 point. When we draw it, it's going to look like more than 1. We have 2 common external tangent lines because these lines never intersect through the center of either of the 2 circles. And they are in common to both of the circles, and they would intersect them in exactly 1 point each. We have a few rules for tangent lines. If a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. So what you can see here are right triangles. We could use things like Pythagorean theorem, SOHCAHTOA, and other things to help us find different lengths now for the radius, or for a segment, or for a piece of a line or segment that's inside or outside of the circle. Another rule we use are tangent segments are congruent from the same exterior point. That means that the distance from A to B is the same as the distance from C to B. These are called tangent segments if they're measurable. a tangent line, if the line segment kept going, would make the line going through here just as we saw before with the tangent line. It still has to intersect in a point. Here's a way we can test if a segment is tangent to a circle. The example says, is CE tangent to our circle D? So we check. We want to know, is this a right angle over at E? So we check to see and do the math. Is 11 squared plus 43 squared equal to 45 squared? So we're checking now to see if 121, which is 11 squared, plus 43 squared, which is 1849, does that equal 2025, which is 45 squared? If the answer is a yes, that would make our angle here a right angle. If the answer is no, then we know it's not a right angle. So does it equal? Let's check it and do the math. So if we add these two numbers together, we can see that they're clearly not equal. So the answer, is this the line tangent? The answer is no. Our explanation is checking the math. Here we have two tangent segments. The question is to find the value of x. So we simply set x squared minus 4 equal to 21 because we know that the tangent segments are equal. If I add 4 to each side, we'll do the algebra. We get x squared is equal to 25. We have two choices, x equals 5, or we could say x equals negative 5. In this case, we check the problem. Since it's an x squared, we could actually put in either number and it would work. If it was just, let's say, an x in the problem, we have to go back and check it. So here's our answer. And that's it for our lesson.